super short notes today. Just a reminder, to find vertical asymptotes, you are looking at where the denominator equals 0. And this means that there are certain graphs that have some very, very unique looking graphs because of those asymptotes. So in number 5, where would these graphs have a vertical asymptote? So in number 5, the bottom is 2x plus 5. So we learned yesterday that we would do 2x plus 5 equals 0. Subtract 5 on both sides, and then divide by 2. It would have a vertical asymptote at negative 5 halves. Take a look at number 6. If we put x plus 6 times x minus 7 equal to 0, if the first set of parentheses is 0, the entire thing is going to be 0. If the second set of parentheses equals 0, the whole thing's going to be 0. So this is going to equal 0 at negative 6 and at positive 7. If we plug this one in on Desmos, it has 2 vertical asymptotes. It has a vertical asymptote at negative 6. It also has a vertical asymptote at 7. So if I zoom in here, you can see at, whoa, it's moving around, at negative 6 and at positive 7. So that's positive 7 right there. And then over here is at negative 6. So it makes this double hyperbola because there are multiple vertical asymptotes. So the more factors you have in the denominator, the more vertical asymptotes you have. So, I mean, I know this is just me kind of being a dork here, but we could go in here and do x plus 2, x minus 1, x plus 3, however many you want, and then you've got this multiple hyperbola thing with all of these little doodads. It's fun. Or maybe I'm just a dork. We'll see. The horizontal asymptotes for this particular format, remember it is where A, oops, this is a typo, where A divided by C. So the numbers that are in front of the x's, you do those numbers, the A value divided by the C value, that will give you the horizontal asymptote. So number 9 and number 10, find the vertical and horizontal asymptotes for each of these. So I want you to pause the video and on your own find the vertical asymptote and the horizontal asymptote for both number 9 and number 10. Number 9, the vertical asymptote would be where 5x minus 1 equals 0. That would be at positive 1/5. The horizontal asymptote would be 3/5. Number 10, the vertical asymptote, that one's pretty easy, would be negative 1. And the horizontal asymptote, we've got 4 divided by 1. So the horizontal asymptote is at 4. On these two where the notes want us to graph, oh, hey, my range didn't show up here, so we need to add range down here. That's cool. Again, pause the video and find the vertical asymptote, horizontal asymptote, the domain, and the range. And I would also like you to use dashed lines to draw those vertical and horizontal asymptotes onto the graph. We're not going to actually graph these, but I want you to draw those asymptotes onto the graph so that I know that you know, that I know that you know, that I know that you know where exactly those asymptotes are so that you could accurately pick out the graph that matches. Okay, number 11, the vertical asymptote is at negative 2, horizontal asymptote at 1. So draw in those asymptotes. If I was taking the quiz on on my paper, I would draw a little coordinate plane, and I would do, okay, -2 somewhere over here, +1 is like right there. I would make that sketch on my paper so I could then look at the 4 graph options and pick the one that has the asymptotes that look like that. Now, there might be one graph, if the vertical asymptote is supposed to be at -2, there might be another graph that has a vertical asymptote at -4 with the horizontal asymptote where it's supposed to be. So make sure you do look at those values. This needs to be at -2, not at -4. So I might make it so that the asymptotes look like they're in the correct quadrant, but you really need to look at those numbers to be sure that you're grabbing the correct asymptotes. In number 12, I threw this one in there to kind of throw you for a loop. This is that type 1 hyperbola. Do you notice that there's no x's on the top? So your vertical asymptote is -3. That's the same no matter what type of hyperbola you're looking at. But in this type, there's no x on the top. So the horizontal asymptote is not at 2 because we only do that when there's x's on the top. Here, the vertical asymptote, the horizontal asymptote would come from whatever's added or subtracted after the fraction. So this one has a horizontal asymptote at 0. So x equals -3, y equals 0, domain and range. You may, on your assignment today, want to practice plugging these into Desmos just so that you can verify that you are getting the asymptotes that you're supposed to and that you will be able to pick out the correct graph on your quiz. So on your assignment is worksheet 3. It's, oh, hey, there's 2 more. Do you want to do 2 more? We good? We good? Okay. So on your assignment, it's called 7.2 Worksheet B, and then in parentheses it says that it's worksheet number 3 in this packet. There's 4 graphs. I want you to find the vertical asymptote, the horizontal asymptote, the domain, and the range. And then I want you to draw the asymptotes with dashed lines. So that's all you need to do on the assignment. You don't need to actually plug it into Desmos. You don't need to find the points. You don't need to put the hyperbolas on the graph. I just want you to identify vertical asymptote, domain, range, vertical, horizontal asymptote, both asymptotes, and use dashed lines to draw those asymptotes in, because that's going to make sure that you know where those asymptotes are so that you can pick out the appropriate graph.